Oh, no, it's not. Okay, so today we're going to do branch analysis. So as you can see, I gave you reactants, reactants, and reactants. So the only thing we need to do is add our angles. Inductors, positive 90. Capacitors, negative 90. Okay. So now we have to figure out how many unknowns. And remember, when we're solving for branch, we're solving for current. So if two things are in series, they would have the same current. So we're going to name these two I1. And then we're going to put our polarities, plus to minus, because we're entering that way. And then we're going to go here, I2, because that's an unknown, plus to minus. And then these two are actually, they're in series, so that would be I3, right? Because we're solving for current, so we're solving for the current here, and the current here. Okay, so now we have to write our first equation. There's 3 equations, 3 unknowns. I'm going to start here and write everything around this loop. And then I'm going to start here and write everything around that loop. And then I'm going to have to do a KCL because we need 3 equations. So I'm going to start here. The first thing I'm entering is 950 at an angle of 90, and that's I1. Make sure you put the I1 plus 2K I1 going around. We're into the negative side, so it's minus 5K I2. We're entering this negative sign, so negative 16 at an angle of 0, and now we're back to square 1. So we set it to 0. Then we put all like terms together. We put I1, I2. If we didn't touch I3, it would be 0 I3. So we have 2 terms for I1. So we do open parentheses, 950 at an angle of 90 plus 2K, and these are I1 terms. This is I2, so it'd be minus 5K I2. We didn't cross over I3, but we want to put the placeholder because that's how we put it into simultaneous equations. So we can do plus 0 I3. This voltage is going to go to the other side of the equation, so we always change the sign. So it's going to be a positive 16 at 0. And this is our first equation. Then we have our second equation. We're going to go around here. We're going to start here and go around. So we have plus 5K I2 plus 10 at an angle of 0. This is plus minus, plus 3K at negative 90 I3 plus 950 at an angle of 90 I3. And now we're back here, so we set it to 0. Now we fix up our circuit, I1, I2, I3. Notice we didn't touch I1. So it's going to be 0 I1. Here's I2, there's only 1, so it's plus 5K I2. There's 2 current terms for I3, these 2, plus 3K at negative 90 plus 950 at an angle of positive 90, and these are I3, equals the voltage. So this voltage must go to the other side of the equation, so it now becomes a negative 10 at 0. That's our second equation. So when we run around the first loop and the second loop doing our KVLs, we've used all of our resources. So we now need to write a KCL. I'm going to write it right here, KCL. Because at this dot, I have I1 and I2 entering. And I3 entering. Okay, So we're always going to write it leaving equals entering because of nodal analysis. So at this dot, what's leaving? Well, no, this would be leaving. Leaving. Okay. So we have I3 is leaving equals entering, which is I1 and I2. So we can swap the whole term and make it I1 plus I2 equals I3, but this I3 has to go on that side. So it becomes a negative. So we have our last equation is I1 plus I2 minus I3 equals 0. That's our third equation, and that's it. You don't have to solve for them. Bye.